Okay, let's do problem 61, rotate list. In this question, we are given the head of the list, and then we have to rotate the list to the right by k places. So here we have 1, 2, 3, 4, 5, and after one rotation, this 5 goes to the front, and after another rotation, this 4 goes to the front. So we can just return 4 as head. In example 2, we have 0, 1, 2, and after 4 rotations, we get 2, 1. But if we carefully look at it, this 0, 1, 2 is exactly same as after 3 rotations. It is because the list remains the same after n number of rotations, where n is the length of the list. So doing it this many of rotations is waste of computation, because we can normalize our k value by doing k equals k modulus length. So in this example, it would be 4 modulus 3, which gives us 1. So we could have just rotated once. So if we rotate once, we get 201, which is same as our answer. So to do that, we need to know the length of the list. And to do that, we need to go through each of the nodes until the next one is known. So while looping this, we are working out the length, but we are also working out where the list ends. So by the end of rotation, we would have found out 5 is the end of the list. So we're going to call it tail, and then we are given with head. So we need to play with it a bit. And my initial approach was having dummy here, just because head is constantly changed, we often use dummy. And to do that, we move tail to the front, make dummy to point to tail, and then tail point to head, and then make this one to head, and then make this one to new tail. But to make this one to new tail, this tail needs to know, or for each notation we need to know what's behind it, but it's a singly linked list, so we don't have any information about the previous one, so this method is invalid. There's actually a better method, which is creating a circular loop, meaning that we make this tail to point to head. So this whole thing becomes a cycle, and what we need to do is we are given length of 5, and then we are given length of 2, and then we do know where tail is, and then we do know where head is. So let's see what we know. So essentially we need to break it here, and then this should be head, and then this should be new tail. So from starting at tail, if you do 1, 2, and 3, that means we found the tail, so that we can just do tail done next is equal to new head, or head equals tail done next, and then we can say tail done next is equal to null, and then we can just return this head, so that this cycle breaks and we have obtained a new head. The question is, how many times do we need to loop from tail? So I can assume that because we've done 3 times and then we are given length of 5 and k is equal to 2, if we do length minus k, it's going to give us 3, but let's just double check on this one. So if we have, how many here? If you 1, 2, 3, 4, 5, 6, and then say k is equal to 2, and that's tail, we do know that we need to break it here. How many times do we need to do? 1, 2, 3, 4. So we can just say that we need to loop length minus k times. All right, so now that we know everything, we can start writing the code. So we can say list node tail equals head. So if this is tail. How many loops do we need to do it? 1, 2, 3, 4. So we need to do it 4 times when there are 5 nodes. And that means while tail.next is not equal to null, that means here we're going to update our length, but we're doing it 1 less times. So it should be int length should be 1 rather than 0. So tail is equal to tail.next and then length plus plus. So by this time we would have got head, tail, and length of 5. And then let's connect tail to head now. Tail.next is equal to head. Now let's normalize our k value. So k is equal to k modulus length. And then we need to work out how many loops we need to go from tail. So int steps is equal to length minus k. And then for int I equals 0, I is less than steps, I plus plus, tail equals tail dot next. After this for loop, we have our tail here, and we need to return head. So list node new head is equal to tail dot next, and then we can say tail dot next is equal to null. So we are breaking this chain. Now we can return new head. And let's think if there are any other edge cases. So for example, if head is known, like just a typical one, if head equals null, what do? We just simply return head. Or if head.next is equal to null, we can just simply return head as well. Or if k is equal to 0, we can return head as well. Okay, let's see. If head equals null or head.next, are we missing something? Okay, let's submit. Okay, that's it.